Hi year one, your turn again for math skills. It is very nice to see you and I can't wait to do a little bit more maths with you. To get us started, we've got that key vocabulary that we must get into our head, because once we know that key vocabulary, that helps us talk about the maths that we see. So when you're explaining to that person that you're sitting next to, these words could come in really, really handy. Are we ready? Let's take turns. Part, part, whole, whole, double, double, half, half, more, more, fewer, fewer, equal, equal. Great. We are going to spend a moment just to compare these two bits of vocabulary. So we've got more. So when we've got more of something, yeah, you're right, you have a lot more. So you've got lots of that object. So if I get more sweets, somebody's giving me more sweets. But if I get fewer, I've got fewer sweets than my friend, yeah, that means he's got more. And I don't have as many. So my number is smaller. Good work. Brilliant. We're going to move on to 3 different activities today. And the first activity, I think we're going to quite like it. So everyone, this is my house. And this is the house of this number here. I wonder if you can read this number at the top of my board and tell your partner. Yeah, you're right, it was the number 25. So this is the house of 25. The house of 25. And there's something special about my house of 25. Yeah. If you are 25, you are allowed to enter my house. But if you're not 25 and you don't represent 25, you are not allowed in the house. So I'm no longer allowed in the house because I'm no longer 25. Ask your mums and dads if they're allowed in the house. Are they 25? No, I don't think so. Are you 25? You're not allowed in the house. I wonder if any of these representations will be allowed in our house of 25. Should we see? I want you to spend a couple of moments looking at my different representations and see if you can spot any that can enter my house of 25 and any that can't enter my house of 25. Off you go. Pause the video if you'd like more time. Right, great. The first one that caught my eye was the Numicon. We're great with Numicon. Should we see if that is 25? What are the blue Numicon? Yes, they're 10. So let's count in 10s. 10, 20, and 25. Yes, we know that that's 5. We're so used to seeing that. 10, 25, 25. So yes, the Numicon is allowed in the house of 25. So let's say bye the Numicon. Defended the house. Are any of these other representations 25? I wonder. Or are any not? Yeah, I think some of you have spotted that the part whole model, when we've got a part of 20 and a part of 4, that actually only makes the whole of 24. Well done. Make sure you got those digits the right way around. So no, the part whole model cannot enter the house of 25. What about the number sentence? Can the number sentence add enter the house of 25? 20 add 4. Yeah, that is only equal to 24 also. So no, the number sentence cannot enter the house of 25. Can any of these other ones enter the house of 25? Oh, we've got tens frame. Does the tens frame represent 10, 20, 25? Yes, so the tens frame can enter the house of 25. Let's just double check. 10, 20, 21, 22, 23, 24, 25. So yes, the tens frames can enter the house of 25. So well done if you manage to spot that. Next, should we jump to the money? Who's really good with money? Who's been going to the shop really carefully, spending some money? Wonder what coin this is. Any of you know what coin that might be? Yes, so that's a 20 pence coin, and this is a 5 pence coin. So we've got 20 and 5, 25. Brilliant. So we've got a 25 pence can go in the house. Are you sure? Can they go? Yes, we can put the 25 into the house. Now, we have got our 10s, our 10 sticks there, our base 10 sticks, and our 1s. Does that represent 25? Who's really good at counting in their 10s? Let's double check. 10, 20, 30, 40, 50, 51, 52, 52? Can 52 go in our house of 25? No, it can't, can it? I think they might have mixed their 10s and their 1s up. So let's have a little look inside of our house of 25 and see who we had in there. Yes, we had the coins, 20 and 5, 25 pence. We had the Numicon, 2 10s and a 5, 25. And we also had the 10s frame, 2 10s and a 5, 25. So we had 3 different parts that could go into that house of 25. Well done if you managed to spot them. Now this is an activity that we have done before if you have joined in some of these lessons, so you should be familiar with this. I want you to look at our tens frame to see if you can spot each part to ultimately try and find the whole. Because our sentence reads, a part of and a part of makes the whole of And I'm not quite sure. Do you think you could finish my sentence off for me? Complete a part whole model to help me find the solution to this problem. A part of and a part of makes the whole of Off you go. Yes, that's great working from some of you. Some of you ultimately started with that part of 5. Yes, you found that part of 5 and a part of 4. But what did it make the whole of? A part of 5 and a part of 4 makes the whole of 9. Shall we double check? Don't need to count 5. We know that that's 5, 6, 7, 8, 9. So we know a part of 5 and a part of 4 makes the whole of 9. My turn. A part of 5 and a part of 4 makes the whole of 9. Part of 5 and a part of 4 makes the whole of 9. Great work. Let's fill in our addition number sentence. So a part of 5 add the part of 4 is exactly the same as, so is equal to the whole of 9. Well done if you managed to spot that. Next, same sentence. A part of and a part of makes the whole of Do you think you can help me out? What does the red part represent? What does the yellow part represent? Do it in your part whole model. Even see if you can finish your addition number sentence. Off you go. Pause the tape if you would like more time. Great. Anyone spotted anything about the red part? Yeah, the red part is only 1, 2, 3, 4 this time. So it's only 4 in that part. See if we've got that. We've got a part of 4. I wonder what the other part might be. Yeah, the other part's 5, isn't it? So we've got another 4, 5. So a part of 4 and a part of 5 makes a whole of 9. So a part of 4 and a part of 5 makes the whole of 9. Can you say that with me? A part of 4 and a part of 5 makes the whole of 9. And again. So if a part of 4 and we add the part of 5 and we get that to be equal to the whole of 9, what did we notice before? So we've got a part of 4 and a part of 5 makes the whole of 9. Here we've got a part of 5 and a part of 4 making that whole of 9. So we had the 5 the first time, but then we had the 4 the second time. So when we add 2 parts together, it doesn't matter in the order, we still end up with the same whole. So 2 parts adding together still makes the same whole no matter which order we add them in. So remember that when you're doing some of your adding, because sometimes it's easier to add one way than it is the other. What do we notice about the whole this time? The whole. We know that this is a whole of 9. So what's this whole? This whole is still a whole of 9. We haven't changed that whole. So we've got the whole of 9. So we know that these 2 parts are going to add up to equal 9. But I wonder what those parts might be. That's your turn. Off you go. Have you figured it out? So the red part is 5. Remember, we don't need to count them. We know that that's 5, 6, 7. So we've got a part of 7. Shall we see? Does that show a part? It does. It shows a part of 7. So we've got a part of 7. And what else do we need to get to that 9? So we've got a part of 7. Yes, and we've got that part of 2. Some of you might have spotted that one nice and quickly with the number being nice and low. So a part of 7 and a part of 2 makes the whole of 9. Your turn. Part of 7 and a part of 2 makes the whole of 9. Lovely. So when we are adding those parts together, so 7, add the part of 2, yes, it is the same as or equal to the whole of 9. Well done. I wonder if I started with the number 2. But I still wanted that whole of 9. What would be missing? Tell your top partner what you think might be missing. Yes, you're right. It is that part of 7. It doesn't matter which order we add those 2 parts together. They will still give you that same whole when we have one part the same and the whole the same. So good spot. Now, might be spotting a pattern here. Off you go. I want you to finish that sentence. A part of and a part of makes the whole of Write it in your part whole model. Write it in your addition sentence, but please match my tense frame. Off you go. Pause the video if you'd like more time. The first part should be easy to spot. Yes, a part of 1. Some of you might have already spotted that actually, yes, it is the whole of 9 again. We've got the tens frame, we've got 1 less. We should be spotting that that is a whole of 9. So we've got our whole of 9. We know that one of the parts is worth 1. What's the other part? Yes, it was 8. So we've got 4 and 4. 4 and 4 is 8. So we've got a part of 1 and a part of 8 makes the whole of 9. A part of 1 and a part of 8 makes the whole of 9. There you go. A part of 1 and a part of 8 makes the whole of 9. Great work, well done. So a part of 1 and a part of 8 makes the whole of 9. So if I have 1 and add the other part of 8, we are going to equal the whole of 9. So I wonder, if I started with that part of 8 and I added something else, how might I get to that whole of 9? This time I'm starting with the part of 8, and you're right, I just need to add the part of 1 to get me to that whole of 9. So good spotting patterns with those relationships there. Get moving. So now, got a tens frame. We've had a little look at some of the number relationships already. So we've got 5 and 4, 4 and 5, 7 and 2, 8 and 1. Those are the ones we've already looked at. I want you to see if there's any other way we can represent this same whole. So the whole does not change. How can we represent this same whole in any other ways? Off you go, that's your job. Pause the video if you'd like more time. Yes, great, good spot. Yes, you'll know straight away that this is the whole of 9. That's the whole of 9. That's the whole of 9, because 7 and 2 make the whole of 9. 8 and 1 make the whole of 9. 5 and 4, 4 and 5 make the whole of 9. What did we notice about these two-part whole models? Yes, I've just switched the parts around. So I wonder if you've done the same. So 2, part of 7, the whole of 9. Part of 1, part of 8, the whole of 9. Anyone get any other pairs of numbers? Yeah. Part of 6, part of 3, the whole of 9. Now I wonder if rub them out and we went again, a part of 3 and a part of 6, it's the whole of 9. Some of you might have even gone part of 9 and a part of 0 gives us the whole of 9. So well done if you managed to think outside the box and spot some of the other pairs that make that whole of 9. We've got a different whole for you now. I know we've worked a lot with 9. We've got a new whole. Firstly, I need you to figure out what the whole might be. The whole does not change throughout this exercise. This is your whole. I need you to tell me the different parts that might make this whole. You can write it in part whole models. You can write it in your number sentences as well. How many different ways can we make this whole with 2 different parts? Off you go. Pause the video if you'd like more time. So, is anybody spotted the whole? The whole is 7. Great, so every whole should be 7. But you're right, there are different ways we can make this whole. So some of you might have had 1 and 6. You're right. Some of you might have had 2 and 5. Some of you might have had 3 and 4. I wonder if any of you swapped them around and had 6 and 1, 5 and 2, 4 and 3. And I wonder if any of you thought outside the box and had a part of 7 and another part of 0 to get your whole of 7 as well. So well done if you managed to spot any of those. Put a part of 1 and add a part of 6 will give you the whole of 7. Part of 6, add that to a part of 1 and that will equal to the whole of 7. So any of those pairs there will add to that whole of 7. So well done. Right, we've got a little bit of a new activity here. So we are going to be comparing some numbers. Okay, and our numbers are going to be shown to you by the Numicon here. And we're going to try and introduce the use of signs to help us in mathematics. We've already looked at a couple of signs already with our add and our equal to, but I wonder if we know what these, start recognising what these signs might mean. Okay, so we're going to be using this vocabulary: more than, fewer than, equal to. Great, so we are going to see if this number is more than this number, or whether this number is fewer than this number, or whether this number is equal to this number. But first of all, we must find out what these numbers are. So great, have a little look at that first number. Who thinks they can spot what that number might represent? So we've got 1 10, 5 ones. Yes, it is the number 15. So we've got the number 15. And what other number do we have? 1 10, 2 ones, 15 and 12. Fantastic. So we've got 15 and 12. So now we need to figure out whether 15 is more than 12, 15 is fewer than 12, or whether 15 is equal to 12. Off you go, which one? Which one do you think it is? Yes, it was. It was 15 is more than 12. 15 is more than 12. And everyone, this is our more than sign. So 15 is more than 12 because we can fit more in this part of our sign than we can this side. 15 is more than 12. 15 is more than 12. 15 is more than 12. Brilliant. So we might say that as 15 is more than 12 because we can fit more in that part. Good work. Same activity, everyone. We are trying to find out whether this number is more than this number, or whether this number is fewer than this number, or trying to figure out whether this number is equal to this number. Your turn to figure out what these numbers are first of all. So what is this number, but also what is that number? Off you go. Right, great. Shouldn't take us too long, especially if you're whiz with Numicon. This is the number 9. Yes, the purple is the number 9. Make sure your number formation is great. And yes, this is 2 10s, which is 10, 20. So we are now trying to figure out whether 9 is more than 20, 9 is fewer than 20, and 9 is equal to 20. So if I had 9 marbles, 20 marbles, have I got more? Have I got fewer? Are they equal? So yes, you are right. 9 is fewer than 20. So 9 is fewer than 20. So we only have 9 holes in our Numicon shape in comparison to our 20 in these two Numicon shape. So 9 is fewer than 20. 9 is fewer than 20. Lovely. And everyone, this is our fewer than sign. Some people say less than as well. Because we can fit less and we can fit fewer in this part of our shape. Okay, so fewer than. We can't fit as many in there. So 9 is fewer than 20. Okay, so that would be the same as that sentence there. Some people say less than as well. Are we ready? 2 new numbers to compare. We are trying to find out whether they are more than, fewer than, or equal to. Is this number more than, fewer than, or equal to this number? First of all, you need to write what these 2 numbers represent. Off you go. Brilliant, we should have recognised this as a 10 and a 4, 10 and a 4, 1 10, 4 ones is 14. And this is a 10 and a 9, so we've got a 10 and a 9 is 19. So we now need to figure out whether 14 is more than, 14 is fewer than, 14 is equal to 19. 14 is fewer than 19. Yes, 14 is fewer than 19. We can't fit as many in this part as in this part, so this is our fewer sign. So another way we might see this sentence is 14 is fewer than 19. Some people say 14 is less than 19. Well done if you managed to spot that. Ooh, interesting. Do we notice here we've got 2 numbers to compare, 2 different ways to represent those numbers. First of all, we need to figure out which of these numbers is what. Off you go. Great, what have we found out? 10 and a 4, 1 10, 4 ones, 14. Same number that was represented before. What have we recognised here? Yes, 7 and 7. What's double 7? Double 7 is also 14. So I've got 14 is more than, 14 is fewer than, or 14 is equal to 14. Which one should we use? You figure it out. So great. 14 is equal to 14. Well done. So 14 is equal to 14. 14 is equal to 14. 14 is equal to 14. Good work. Our last activity, everyone. You have got 3 sets of numbers to compare. We've got 2 is 20, 21 is 12, 15 is 10, add 4. You need to figure out whether more than, fewer than, or equal to needs to go into that gap. Okay, and as a challenge, if you know how to write it with the symbol that we've looked at, so the different symbols, please have a go at doing that also. Off you go. Pause the video if you'd like more time. So 2 is fewer than 20. We've only got 2. 20 would have 2 tens. It's a much bigger number. So 2 is fewer than 20. If you had to go at writing it with the symbol, it should look a little bit like that. So this is our fewer than or less than symbol, because we can't fit as many in that part of the shape. What about this one? 21 is, yes, 21 is more than 12. So 21 is more than 12. So if 21 is more than 12, the symbol will look like, yes, it's the more than part, the part we can fit more in. So 21 is more than 12. Superb. And finally, we've got a little bit of a calculation to figure out first. 10 add 4 is, yes, that's the same as 14. So if we get rid of that, we just think of it as 14. 15 is, no, it's not equal to, that was a trick. 15 is more than 14. 15 is also more than 14, even though it is a lot closer than what 21 is to 12. So let's have a little look at how that might look. So 15 is more than 10 add 4. I wonder what this might need to look like if I was to use an equal sign. What might I change that to be if I wanted to use an equal sign? See if you can figure that out. So if I wanted 15 to be equal to 10 add something, it would have to be 5 instead of the 4. So well done if you managed to spot that. Thank you very much, Year 1. That is your maths lesson for today. I hope you enjoyed it. If you want to do more, please send in a picture and I'd love to see it. Well done.